How El Bulli recipes help us build better software. Actually, behind this captious title, the message I really want to convey is how managed cloud services can empower developers. And here I want to make a side note and talk about a book I have just written about the topic. The book title is Building Software Platforms, and it is written from the trenches. It is based on years of experience at DXC Technology building an internal platform for our business services. I have tried to write the book in the most simple way, always trying to put diagrams and pictures along the text to express ideas, a lot of worldly maps for strategy as well. I think the topic is interesting, so I really hope that you enjoy this book. The thing is that there are interesting and even compelling lessons learned for the software industry that we can extract from the story of El Bulli, a restaurant in the Spanish Costa Brava. To develop this connection, I'm going to use a technique called worldly maps. A worldly map is nothing but a map for business strategy. The components that you want to assess are drawn as nodes on a graph and they are positioned within a value chain and they are anchored by the user need. Then each component in the map is classified both by the value it has to the customer in the vertical axis and by the maturity of that component with movement described by a horizontal axis. As you can see, the maturity can range from custom made or novel ideas to commodities or best practices. Now let's look at how we can map the story of El Bulli. Everything started in 1968 when a couple of chefs wanted to study the scientific discipline concerned with the physical and chemical transformations that occur during cooking. We can say this approach was a new creation, a novel idea. Then, when Ferran Adrià joined El Bulli in 1984, the restaurant was already enjoying a leading position with one Michelin star. But Adrià rescued the principles of molecular gastronomy. With Adrià's ideas, the restaurant popularity rocked thanks to the vast number of innovation they brought into the cuisine, obtaining two additional Michelin stars in 1990 and 1997. Then, molecular gastronomy became a very good technique. El Bulli was differentiating from their competitors based on the technique, based on the function, based on how they created dishes. And this is when the story starts to get interesting. In 1998, and with El Bulli amongst the best places in the world, Adrià took a decision that surprised the entire gastronomic industry and the whole world, as a matter of fact. As he expressed in many interviews, he felt exasperated about going from Congress to Congress and watching other chefs sharing their results of their creations while they kept the secrets and, most importantly, their recipes to themselves. That triggered Adrià's creativity. Then, in one of those conferences in San Sebastian, he proclaimed one of his most famous statements that kick-started a whole movement within the industry. The time of keeping recipes in the drawer is over. After that moment, Adrià started to share all his famous recipes and techniques publicly, Congress after Congress. So, yes, for those of us who work in the software industry, that is precisely what you're thinking. To get better, Adrià open sourced El Bulli's recipes as he understood that the best way of protecting an idea is sharing it immediately. They quickly recognized that the only way of getting there was by accelerating innovation and sharing knowledge with the community to compete in identical product and practice conditions. By releasing their secrets in the open, they transformed their technologies and techniques into an industry standard adopted by many other restaurants on the planet. What actually happened was that the gastronomic industry at that moment started to compete in a commoditized market. But then, what happened after this master move won't surprise you. Adrià and his team outperformed themselves to the point that the restaurant magazine awarded El Bulli as the best restaurant in the world, setting a record high of 5 times. Again, they were competing in a highly commoditized market where most restaurants work with the same products and techniques based on molecular gastronomy. However, not surprisingly, El Bulli was again leading in this very competitive market and differentiating themselves from the competitors using their techniques to produce unique dishes. They were no longer differentiating on the function. They were differentiating on operations, on the service. However, little did they know that they were about to die of success, except for one person, the visionary chef. Adrià started to witness the first signals of burnout in his increasingly mature team. Although, more importantly, he was very frustrated by the fact that he had to reject customer after customer because the restaurant's waiting list extended for months and even years worth of reservations. El Bulli even had to cancel lunchtime service to focus on one service per day at dinner time. Estimating that the team couldn't physically and mentally make it beyond 2012, Adria closed the restaurant in July 2011. Although El Bulli as a restaurant has closed forever, the core concept, together with Adria's vision, didn't stop there. In this spirit of experimentation and innovation that led El Bulli to become the number one restaurant, Adria's next project will consist of spinning up a foundation to foster gastronomy innovation, learning, and sharing experiences with the community. That's what we know as El Bulli Foundation. So this is a very important lesson. This is what we called inertia. Inertia basically is dying of success. It kills you slowly without you noticing. It happens to every successful business. And you have to be very conscious. You have to develop a very clear situational awareness of where are you playing in the market in order to anticipate. And Adria did it. What happened then is that by opening El Bulli Foundation, what Adria is really doing is going back to basics, going back to that uncharted area of the evolution where new creations happen, novel ideas are developed. What the history is telling us is that during the coming years, and thanks to competition, Adria and El Bulli Foundation will be able to release new gastronomic ideas to the world to give us a better future. And I think there is a hidden lesson for the software industry, despite these stories evidence survivorship bias and the manifestation of privilege that entails closing a wealthy business at its peak. So, what is this lesson for the software industry? There is nothing magical in the source code of your product that makes it irresistible for your customers to own it. The service is what matters. And this is very, very important because it has multiple and essential implications in the technology direction and in the architecture of our services. To explain why, let's look at the worldly map again. The software product market is very competitive. So, unless you are entering a new market with a revolutionary idea at its genesis, it is very likely that there are hundreds of products like mine. Under these circumstances, we are in that part of the evolution where we are competing on product. And when that happens, the best service always wins. And that is what happened to El Bulli actually. In a market where everybody plays with the same methodologies and raw materials, you need to differentiate on your service. And that is why moving to software as a service is so important. If you don't do it, one of your competitors will. But what does it have to do with managed cloud services? Okay, we are now getting closer to the essence of the message I want to convey. Let's look at this using worldly artifacts, and in this case, only the vertical axis where we can see the value chain. At the top, we always have our clients. What happens then is that developers build applications that solve concrete business problems to those customers. That is where the value is created. But we also know that there are a lot of surrounding responsibilities for developers nowadays, especially in the world of microservices oriented architectures and cloud computing. There is an ocean of additional responsibilities for the developers when they need to create those applications. These may include things like a little bit of infrastructure management, setting up build and deployment pipelines, also dealing with a number of cloud computing services, and of course working with multiple third-party APIs. All that is pure undifferentiated work. That's only the cost of doing business, and we need to reduce the amount of time that developers spend in this part. Why? Well, the main reason is because that is invisible to our customers. Although it is very important for our software to run successfully, our customers do not care how we manage that part. They only care about how we are solving their problems with functional software. Okay, so let's look at how the product-based economy attack this problem. Here, the principal need is deploying the software product on multiple client environments simultaneously. As software product developers, we need to design and build the product so it is deployed across these heterogeneous infrastructures. Of course, the challenge is doing it at scale without building different versions of the product for different clients. One of the most popular and accepted solutions to this challenge is using agnostic technology. These are typically frameworks or technologies that lay down an abstraction layer between our product and infrastructure. By using those, we only build one version of the product, and technologies such as Kubernetes manages how our product behaves in those multiple infrastructures. They do all the heavy lifting for us and all the container management and abstracts our software from the details of the underlying infrastructure. But how is this done in a service-based economy? Here, the principal need is delivering software as a service over the internet. There are no portability requirements. The challenge here is doing it at the minimum cost possible, since the software provider, this is us, we own the cost in their totality. In this particular case, the clients only care about receiving good functional software, and they do not care about how providers build or release that software. So, what technology can I use to build my software as a service? Of course, one can think that using agnostic technology is fine. The challenge, though, here is that there is a risk for the development teams to spend too much time managing infrastructure, managing clusters. On the other hand, using managed cloud services means that we are consuming all that as a service. Therefore, the developers will spend less time managing infrastructure that is given by the cloud provider so they can focus on building value. They will spend more time on building functionality for our customers. What is important in the service economy is that we must minimize undifferentiated work, which is nothing but cost of doing business, and we should maximize the functionality, which is the delivered value to our customers. As Werner Vogel, CTO of Amazon.com, said in reInvent 2017, in the future, all the code you ever write is business logic. Well, managed cloud services allow us to externalize complexity at low cost. Let's be careful though, because complexity is like energy. It is transformed, it never goes away. So even if the cloud provider manages these complexities, the trade-off is a non-zero cost one. Let's see this in detail. The history of software architecture is one of adding layers of abstraction generation after generation with the goal of managing complexity. With that in mind, managed cloud services are the latest layer of abstraction in modern computing aimed at helping you reach a peace of mind. It does so by handing over a significant part of the infrastructure management complexity to somebody else, which is in this case a specialized cloud provider. By going one level up in their managed services stack, the cloud provider supplies you with auto-scalable, pay-per-use. Actually, they are managed runtime engines for your applications, and they do it as a service. All this results in a new architectural style, mainly driven by the economic forces of a commodity-based market. This is serverless. We don't want our development teams to cosplay as cloud providers. Of course, I understand. You are worried about vendor locking, but you shouldn't. Let's look at this again using worldly maps. Remember that your organization is now transitioning towards software as a service, so you own the cost of the assets in their totality. For that reason, you may not have a portability requirement to multi-cloud or on-prem, nor the need to share software code between multiple platforms. So in more traditional environments so far, developers and operations teams together handle runtimes as products. You had to download those runtimes from the internet or buy them from a vendor and then together manage them so we can introduce changes without breaking the system. That's what DevOps is all about. However, these are type of architectures are still very product centric towards developers. This is, we still have to rely on some sort of products from the market in order to produce some kind of value to the developer so they can focus on solving business problems. However, times are changing and cloud providers keep industrializing runtimes and keep offering them as a service to us. This is what we know today as serverless. It's nothing but runtime as a service. Of course, with the industrialization of infrastructure as a utility, a huge number of libraries and technologies are emerging to help developers handle infrastructure on their own. Also, those infrastructure as code technologies are enabling a co-evolution of practice that we sometimes call no-ops, which means that developers do not need any intervention at all from the operations team to get a job done. That is an emerging practice. It is in its genesis somehow, but it's already offering more value than a traditional DevOps. Also, serverless is enabling a kind of new design approach to our software, a more true service oriented approach, what we call a serviceful design. Not serviceful like full of services, but with the characteristics of services. Technologies such as AWS Lambda allows us to do a more fine-grained design of our architecture. There's nothing in the principles of serverless that says that you couldn't build a monolith using those technologies. It just doesn't make sense. What happens is that when infrastructure is offered as a utility to developers, then it is easier to design self-contained, loosely coupled, and highly cohesive business services. Then this coevolution of technologies and practices around serverless enables a more developer-centric type of architecture, which is the internal platform architectural style. Now, you no longer buy the best product technology for developers by default. Instead, you build it so they can solve core business problems. Software engineering and architectural leaders have all the necessary technologies and practices at hand to make developers focus on providing business value. So, what does it mean in terms of application portability? So, we can say that vendor lock-in is an illusion. Serverless technologies are based on standards. That's precisely how they became commodities. Also, it's very important to highlight that the cost of managing infrastructure is higher than writing the code twice in the unlikely event of switching providers. To support this idea, I'm going to bring up an article written by the Dropbox engineering team. The article, with the title The Not So Hidden Cost of Sharing Code Between iOS and Android, is a beautiful display of this principle. Within this compelling story, there is one paragraph that took my attention and that can be totally applicable to the cloud world. By writing code in a non-standard fashion, we took an overhead that we would have not had to worry about had we stayed with the widely used platform defaults. This overhead ended up being more expensive than just writing the code twice. Now, think about this from a cloud prism. The platform default is serverless, and the non-standard fashion is using cloud agnostic technologies. This is brutal. You don't have to rewrite all the code. Evolutionary architecture gives you patterns to do it with confidence. Behind this fancy name, this architectural pattern can help you achieve agility in your design. Also known as hexagonal architectures or the ports and adapters architecture, this pattern is used for encapsulating domain logic and decoupling it from other implementation details, such as the infrastructure or client requests. Basically, it supports guided and incremental changes across multiple dimensions. The goal is to isolate the business logic from the environment where it is executed by means of layers of responsibilities. Here, the domain logic represents the core of the application, the task that it should perform, abstracting any interaction with the external world. Ports provide a way for the primary actors on the left to interact with the application via the domain logic. The domain logic also uses ports for interacting with secondary actors on the right when needed. Adapters is already a well-known design pattern for transforming one interface into another interface. Basically, all they do is wrap in the logic for interacting with a primary or secondary actor. The primary actors, here in the left, are the users of the system, such as a webhook, a UI request, or even another system. The secondary actors in the right are used by the application. These services are either, like a repository or, a cloud service. Therefore, a potential cloud provider migration would require rewriting only the input adapter and the output port while leaving the domain logic untouched. I know all this sounds very high level and very abstract, so most probably I'm gonna do a second video explaining this thing in detail.